Hello again, everyone. So last week we did something that looked very similar to this. You may notice there's just one thing that's changed on the board, and that is it now says box plots. And last week it said outliers, but I started to explain what an outlier was by showing you a box plot. That's because you should have met a box plot before during GCSE, and I think they're a good way into thinking about an outlier. So everything's going to be true that you already knew about box plots if you did. If not, don't worry, you can find out now. But also, those outlier things would come in. Here it says this is the smallest value and this is the biggest value. But that's not always true. Because if there is an outlier, that outlier will be beyond what we've got there. So if an outlier was too big to be acceptable within the data, we would put it out there further on the scale, and that's what we haven't got here at all. This is just an abstract picture of one, but I will show you ones with scales and we will have a little go at those now. Okay, so the biggest reason for using box plots as much as anything is to compare two sets of related data, which is what we're going to do here. Now at the top it's asking us to draw a box plot on blood glucose levels of females from example 1. That's what we did. That's what we were looking at last week or last time when we were doing the blood glucose of 30 females. When we did we're looking for the outliers. So we need to identify the same basic information. We've got the smallest value, but we've also going to have to look out for an outlier. So we know the smallest value is there, we know the biggest value is there. We also know that the interquartile range is going to be at 30 divided by 4 is 7 point something. Therefore, 7.5 to be exact, we take the 8th value, don't we? So 1, 2, 3, 4, 5, 6, 7, 8. That there is the lower quartile, otherwise known as Q3. The median is halfway between 3.8 and 3.8, so we know that the median is 3.8. And then if we go for the upper quartile, Q1, it's going to be, I'm sorry, I've said that wrong, haven't I? Q1 is the lower quartile, isn't it? Q3 is 3/4 up, so that's why it's Q3. So 3/4 of 30 is, we did this last time, didn't we, is 3 times that, which is 22.5, so we're looking for the 23rd value. So that's 15, 16, 17, 18, 19, 20, 1, 2, 3, and there was that one directly underneath there, so that is Q3. Now, that means that Q1 is going to be there, Q3 is going to be there. Right, next thing to do is to put in our axes. And the scale here, we've got 6 that we're going up from. So if we just go from 0, 1, 2, 3, 4, 5, 6. I'm going to just leave off the lowest value for now. We know the median's at 3.8, so that's going to be 1, 2, 3, 4. That's going to be just there. We know that the upper quartile is going to be at 4.0, so very close to it. We know the lower quartile is going to be at 3.2. Last week, if you remember, 1.7 turned out to be an outlier. 5.1 didn't, so I can put my 5.1 in here, halfway between 5.0 and 5.2. Should use a ruler, really. Then, where will our lowest point that we want to register be as opposed to our outlier? Now this was an outlier, so that's going to be registered as a cross. 0.2, 0.4, 0.6, 0.7, so I'll put a cross just there. And if we remember, it was 1.5 quartiles interquartiles, IQRs, from the mean, wasn't it? And the interquartile range was 0.8. So times that by 1.5 is 1.2. And if I go 1.2 below 3.2, I get to 2.0. So I'm going to put my end point there. Sometimes they do the end point just as a shorter one. Actually, normally would do it as a shorter one, but I've already done that. It doesn't actually matter. It's just a stylistic thing. Now it says, given that there's only one outlier for the males, draw a box plot for this data. Well, before we can know exactly whether our outlier is the highest value or the lowest value, we'll need to work out what our interquartile range is, so that we can find where our boundaries for that would be. So the IQR is going to be the upper quartile, take the lower quartile, which is 1.1, and then the 1.5 times that is 1.65, and that is, we need to know how far that is above the lower quartile and the upper quartile. So plus 1.65 in there would get us to 5.25. And if I do the same thing, oh no, not add, is it? It's going to be below. Sorry, take that would be 1.95. Whereas if I added 1.65 to there, that would give us 6.35, which is way off the scale. So our outlier must be 1.4 because it's below 1.95. So let's plot those results on here now. I'm just going to struggle to put that in. So we've got our lowest value at 1.4. We've got our interquartile range finishing at 1.95. So I don't know whether or not 1.95 was my lowest other value. I'm just going to have to assume it was because we've got no more data on it. We've got the median of 4.0, and we've got our upper quartile of 4.7, 2, 4, 6, 7, and we've got our highest value of 5.2. So that should all look like, hang on, just let me add in the lower quartile I hadn't mentioned, had I? 3.246 would be there. Will all look like something like that. I made a bit of a bodge of that bit, but anyway. Part C, it says compare the blood glucose levels for males and females. And this doesn't need to be anything at all complicated. They're just looking for two things. One, that you say what the median is of one compared to the other, and the other that you say what the difference in the range is. So that would look something like this. And here we go. So it's just, yeah, the male's median blood glucose level is higher than the females. You could have said it the other way around. The females is lower, and the males have a larger interquartile range than the females. You don't have to say by how much, though there's no harm in doing that, and you don't have to interpret it unless they ask you to, in terms of anything more that you might think of to do with it. That's it. You don't have to say that the female's blood glucose is more consistent than the males, which is what it actually shows, because therefore they're slightly more predictable than the males too. You don't have to say that. Anyway, we're going to have a look at two more questions today. So I'd encourage you to pause the video and have a go at this before seeing what I would do. So the median mass, important you put that median in, I nearly missed it for a moment, of a female turtle is lighter than the median male turtle, whilst the range and interquartile range, actually you only have to say one of either, they prefer the interquartile, of the male turtles are bigger than the females. So the males are more spread out. Your average males vary more than your average females. B. A turtle was found to have a mass of 330 grams. State whether you think it's likely to be a male or a female. Well, 330, that's 20, 40, so 330 is just about there, isn't it? Just at that point. Well, it's more likely to be female. And the reason for that is because over a quarter of the females are heavier than that, and 3/4 are lighter, but there's only a tiny proportion of the males that are that light. So I've written something down to do with that. And then the last thing, write down the size of the largest female turtle. That would be this outlier here. So that looks like it's exactly 500. So 500 grams. Half a kilo. Quite small turtles, I would have thought. Anyway, time for our final question. Right, here's our question. Give this one a go. So first of all, to find your quartiles, you need to add up how many and divide by it. You should have got something looking like this. So divided 25 by 4, you get 6.25, so you bump it up to the 7th value, and then there's the median and there's the upper quartile. So 22 knots, 26 and 30. Then an outlier is defined as a value which lies either 1.5 times above or below. Show that 46 and 78 are outliers. So the IQR is 30 take 22 is 8 knots. 30, which is the upper quartile, plus 8 equals 38 knots. So anything above that will be an outlier. So we can say 46 and 78 are greater than 38. And then all we've got left to do is to draw a box plot for the data. So before we do that, we just need to think, right, I've got 13 as my lower limit, then I've got my upper limit actually being 38, and then I've got my two outliers looking like that. I've got my Q1, Q2 and Q3 being so. Make sure you draw it now if you haven't done already. And hopefully you've got something like this. Now you may have noticed that I only put the scale in afterwards there, and that's the sort of thing you may well have to do. You'll be given a load of squares and you've got to make a sensible scale, and in order to do that you just look at the data you've got and think, well, what's the smallest amount I could have, what's the biggest, and then you just need something that graduates nice and evenly along there, and there just happen to be 16 big squares going from there, so you could have one little square for each one. Okay, well that's it from me today. See you next time for more representations of data.